Hello everyone, how are you all doing? Welcome to IGBits. We train, you learn. Today we shall continue our topic work per energy. We will see some more sums. Alright, without further delay, let's get started. We have our YouTube channel. Visit us at IGBits in YouTube. Please feel free to subscribe and click on bell icon to get the notifications. Your support is very important for us to work together to share many more knowledge sessions across. Okay. Thank you all who are actually being with us and supporting us. This is a great platform that we are aiming for. Thank you all once again. Work is classified as three types: a positive work, negative work, and zero work. So how do you interpret like whether what is meant by positive work and negative work and zero work, right? So we have the formula work done equal to F into D and F D cos theta, F cos theta and D otherwise, correct? So what we are saying is like mostly even if you say like F is a finite value, D is a finite value, we'll look at like an angle between F and D. That basically tells you whether work is actually positive or negative or zero. Let's say if the value of an angle between the direction of F and D is either 0 or acute angle. Acute means less than 90. That cases you will be getting a positive value, which is nothing but a positive work. Okay. So you always remember 0 or acute angle. In other word, if the angle between F and D, if at all it is 180 or obtuse angle, 180 plus angle, this case we will get like a negative value. So and hence the work done would be treated as a like a negative work, right? In case of 0, if at all the angle between F and D is if 90, what happens is like look at this one, FD cos theta, theta means like 90, cos 90, what is the trigonometric value for cos 90? Which is 0. So FD multiplied by 0 is 0. If the angle between F and D is 90, then work done would be the 0. Let's say for example a man who carries the weight on the head, let's say, right, and then moving the direction, what would happen like the angle between the gravitational force, right, this one, and the direction would be always 90, and hence the work done will be 0. So maybe the man is moving, but with respect to weight we would always see the work done is 0. Those kind of examples we can actually talk about. One important thing that we always refer is what is our typical conditions for zero work. Anybody can recall what we discussed in previous classes? When the displacement is 0, then the work done would be the 0. Obviously, right? When D equal to 0, F dot D is 0. So work done would be the 0, because if you are not looking at any change in your position, then you can say like the work done is 0. That's what this term says. Next one, when the displacement is perpendicular to direction of the force. That's what this case. In this also work done would be 0. The third one, when a body moves under an action of conservation force over a closed path. If it is a closed path, what would happen? The initial position, final position would be the 0, and hence displacement would be the 0. If the displacement is 0, then the work done would be 0. So these are the typical cases we can consider for 0 work. Okay? Very good. Yeah, you're right. So find out the sign of work done by the force for the following cases. Since we know now that work is can be a negative and positive and then 0, we should be doing that part. All right. Let's see what are these cases and how you are going to look at these cases. Right. Whenever we say like in work done, the first fundamental thing that you have to see like the formula. What is the formula that we are actually using that? So we know that the Fs cos theta is the formula that we are going to apply, and make sure I think we'll be able to answer them all. Okay. So W equal to Fs cos theta, Fd cos theta, something like that. So work done, first question, the work done by man in lifting a bucket out of well by means of rope tied to the bucket. That's what is given. So to lift the bucket, now force is equal to weight of the bucket has to be applied vertically upwards. That's what you're lifting. So bucket moves along the same direction of the lift. So the theta would be what? F into S. Both are first case, both F and S are in same direction, and hence what about theta? Theta equal to 0 degree, and hence work done is how much? Fs cos theta. Fs cos 0. Cos 0 is nothing but cos 0 is nothing 1. So Fs. So it's a positive. So F is work done would be the positive. Clear? Let's look at second one. Work done by gravitational force in the above case. So what we are saying is like one is like you are lifting upward direction, but gravitational force is what? Downward direction. When this is a downward direction, applied force is upward direction and gravitation force downward direction. Right? In this case, gravitation for Fg is downward direction, displacement is upward direction, and hence theta would be 180 degrees. Right? So F is cos 90, cos 180, cos 180 value 1 minus 1, right? Minus Fs. So work done would be negative. Clear? Okay. What is the third case? Work done by the friction on a body sliding down an inclined plane. Inclined plane. Friction is always what direction? Opposite to relative motion. No question. Opposite to relative motion. And hence, same case, CF should be opposite direction to the S. And hence theta 180. When theta 180, the work done would be negative Fs. So, negative case. Right? What would be the next fourth one? Work done by applied force on body moving on a rough horizontal plane with uniform velocity. This is what is given. Body moves along direction, along. This is clearly mentioned. A work done by the applied force on the body moving rough horizontal plane with uniform velocity. Okay. If the both are in the same direction, the theta would be what? 0 degree. And hence W is nothing but Fs cos 0. So Fs cos 1, cos 0 means 1, so Fs, which is positive. Clear? Sign is clear. What is fifth one? Work done by resistive force of an air on vibrating pendulum in bringing to the rest. Whenever you say resistance force, this is again opposite to the motion. Whenever you say opposite to the motion, the theta would be 180 degrees, and hence work done would be negative. So this is how we have to identify whether the work done is a negative or positive. Clear? Okay, let's look at this one. This is a very interesting problem statement. This is inclined plane, but gives rise your work done activity. Okay, let me read out. A block of mass 2 kg is pushed down an inclined plane of 30 degrees centigrade. So let's try draw the diagram. This is inclined surface, and then we have block here, right? So this is a normal. This would be your downward direction, right? And then this is mg. So this is mg cos theta, and this direction mg sin theta. We know that, right? And then force applied here because block is moving downward direction. Clear? This is 37 degrees. So we know right angle triangle come. So if it's 37 degrees, what would be your values? Sin theta and cos theta, right? Well done. So obviously this becomes 3, this is 4, this is 5. This is how you can get it. Okay, let's move on. What is given? Acceleration A, so m is given, m equal to 2 kg, and force is given, force equal to 20 newtons. Acceleration A is given and 10 meters per second square. What is asked is applied force in the first term, right? And work done by the applied force. So first work done is what? How to calculate work done? First problem. So W is equal to Fs, F into S cos theta, F into S. So all we require is like S need to be calculated first. How do you calculate S? S equal to ut plus of at square formula you have to use. And then initial velocity, right? Somewhere else I read this is a start from the rest. u0. So this component would be 0 plus f, and acceleration how much? 10, and first 1 second, right? So what is the value here? A equal to s value, right? This one, right? S value would be now 5. So 5 meters per second square is S. Now W equal to force into uh, Fs cos theta, right? And then F and then S are in the same direction, and hence theta would be 0. Cos theta, how much? Cos theta, it would be cos 0, and hence 1. So what would be the value? F is 20 into 5 equal to 100 joules would be the answer. Clear? Let's look at second one. Second problem statement. Work done by weight of the block in first second. Weight of the block is given. Okay. So how do you calculate this one? Here you have to consider mg sin theta component here, and then distance that it travels. So work done by the weight of the block in the first direction is nothing but component of weight in the direction of displacement and displacement. So formula would be component of weight in the direction of displacement. This is what you have to calculate. So work done would be now mg sin theta into your displacement. So m, what is m value? 2, g is 10, and sine 37 degree, and your d would be 5 meters, this one 5. So how much this value? 2 into 10 into how much? This is sine 37, 3 by 5. 3 by 5 multiplied by 5. So this is cut. So 2 3 6 and 60. 60 joules would be your answer. Clear? Let's look at now what is the third problem. What is the third? Work done by the frictional force acting on a block in first second. Again, so what you have to consider is a frictional force is what is considered, right? So we need to calculate the frictional force acting on a block. How do you calculate this one? We have applied force and you have a frictional force and you have a component also there. Equation of motion of the block. So motion of the block, how do you get it here? Mg sin theta, right? Mg sin theta, and then you have a frictional force minus F, applied force F should be equal to your acceleration ma, right? Mass into acceleration. This is what you are considering. So mg means like 2 into 10 into your sin theta value 3/7, right? Plus minus F plus applied 20. This is the frictional part. 20 equal to m into a, 2 into 10. So now how do you say 5 1s are 5 2s are 2 2s are 4, 4 into 3 12. So this is 12 minus F plus 20 equal to 20. So F frictional force is 12. So now work done would be Fs cos theta or Fd cos theta, F dot d. So Fd cos theta, correct? So 12, what is d? So you have the d initially you calculated, right? The d or s whatever it would be, that is a 5, and cos theta would be minus 1 because frictional force displacement are opposite direction, so theta would be here 180 by default. So the answer would be minus 60 joules. Clear? So this is one of the good example. A lot of concepts we have to apply and see like how it arrives you at answer level. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Logically, we reached end of the session today. We shall continue remaining in tomorrow's class. Thank you all who are joined and participated actively in today's class. See you all tomorrow. Stay tuned to next session. Thank you. Have a good day. Bye bye.